The question is, use division algorithm to show that any positive odd integer is of the form 6q plus 1, 6q plus 3 or 6q plus 5, where q is some integer. Now observe here, when compared to your previous questions which I have uploaded on the YouTube channel, in that you were asked cube and square. But here the question is, you have to show that any positive odd integer. So the keywords used here, positive odd integer, and the form should be 6q plus 1, 6q plus 3 or 6q plus 5. Observe the word odd and observe the numbers 1, 3 and 5. Here you don't have to square, and here you don't have to cube. And also, if you observe these forms, the b value is 6 here, because if you compare with this bq plus r, the b value is 6 in all the three. So first, according to Euclid's division algorithm, we'll assume let a be a positive integer, and we have to show that any positive odd integer is of the form 6q plus 1, 6q plus 3 and 6q plus 5. Then as usual, by Euclid's algorithm, a is equals to bq plus r, that is my first equation, and I know the condition in my Euclid's division algorithm is the remainder r should lie between 0 and b. So 0 less than equal to r less than b. Now I'll substitute the value of b is equals to 6 in my first equation, as my form is in 6q plus 1, 6q plus 3, 6q plus 5. There is in all the equation 6 is there. So in place of b, I'm substituting 6. So a is equals to 6u plus r. This is my second equation. Now, since I have the condition 0 less than equal to r less than b, here b I have substituted as 6. So my condition is 0 less than equal to r less than 6. Now, the remainders lie between 0 to 6 means possible remainders are 0, 1, 2, 3, 4, 5, 6. Now here remainders are nothing but here which is assumed in the algorithm, that is r. So 0, 1, 2, 3, 4, 5, 6. But in the question it is asking only positive odd integer. So I will consider, and if you see in this cases also we have 1, 3, 5 which are odd positive integers. So these are compared to 6 bq plus r. So r is 1, 3, 5. There is positive of odd only here. So I will consider only odd integers in this from these remainders. That is from 0 to 6. So I'll just consider 1, 3, 5, 7, etc. And in this only also I'll just consider 1, 3, find my three cases. Because in the first case if I observe it is 1, second case 3, third case 5. So substitute r is equals to 1 in equation 2 in my first case. So a is equals to 6u plus 1. Got the answer compared to this. Now going to second case. A is equals to, substitute r is equals to 3 in again second equation. If I substitute r is equals to 3, it is becoming a is equals to 6q plus 3. I got the case when I compare to this. Now third case I have to prove a is equals to 6q plus 5. So how to prove? Substitute again r is equals to 5 in my second equation. If I substitute r is equals to 5 in my second equation, I'll get the equation a is equals to 6u plus 5. Now compare with this third case. Here I have a is equals to 6u plus 5. Now observe in the previous videos, the letters were given in the question were m or n or p. So but here directly it is given q. So no need to assume anything here. Directly it's given as q. So we are just writing q. That is why this question is shorter when compared to the previous questions, and also you don't have to square or cube anything because it is clearly given in the question that you have to just take positive odd integers. That is why I have assumed odd remainders, and also I have got this form, and I'm not squaring anything. I just need positive odd integer. That is why I assumed a as positive integer. So therefore, hence any positive integer is of the form 6q plus 1, 6q plus 3 or 6q plus 5. Hope you have understood my video. If you have any doubts, please comment below, and if you're new to my channel, subscribe to my channel and like the video and share with others. Thank you.